Right. Wow. Hi, everyone. So how to get engineers to want to adopt app security? It's simple. Yes, it is possible. And yes, it will make your organization much, much better. So, right. Who am I and why am I here lecturing you about how to get engineers to actually want to adopt app security? So I've started my journey in the IDF as a software engineer, computing large sets of data to understand potential intelligence targets. Then I became a team leader. Then I became a machine learning engineer in Salesforce, applying machine learning models to help businesses to convert lead to sale better. And now I'm an engineering manager in an app security company whose sole purpose is to find vulnerabilities in runtime. And we are getting engineers adopting our tool. So I've transitioned from an engineer who actually don't like app security. I really hated it. I got outputs from a tool. I didn't understand 50% of it. I had to go over them by a certain deadline. And I wrote some unsecured code. That's like a statement that I can say to an engineering manager who's getting engineers adopting its tool. So during this transition, I gained a lot of insights. Some of them I'm going to share with you today. Right, so our high-level agenda is I always like to start with the why. What is the problem? Why do engineers don't like app security, don't like dealing with it? And we are in the business of making money, of course. We don't really care about if engineers are having fun or not, but it actually hurts us as a company. So we'll also understand why it hurts us as a company that engineers are not adopting app security. And then we'll discuss the how to solve it. How can we overcome this gap in the KPIs using three stakeholders: the app security domain experts, product managers, and the R&D. And then we'll wrap up with some takeaways. All right, we didn't have to wait for the end to answer this question. It's pretty simple, actually. Why did I hate, and many engineers don't like dealing with app security? The first thing is it's a waste of time. I mean, what is the worst thing that will happen if I don't sanitize some, like, I don't know, a script tag? What will happen if I don't do that? This is something that it's really hard to answer as an engineer. You are tasked with writing performant code. We're dealing with time complexity, memory complexity. We like playing with the big O notation. That's what we learned in computer science degrees. But we didn't learn what happens when we don't sanitize our inputs or we don't correctly encode our outputs. So that's the first thing. It really is a waste of time, and we are feeling like we are wasting our time. We're not doing our job properly. Second thing, I want you to think about this. Here's a list of tools. So GitHub, Jira, Confluence, Grafana, Datadog, Kibana. Those are like tools that I use in my day-to-day, my engineers use in their day-to-day. You can imagine each of those tools is at least one tab open. And now you're telling me that I need to use and learn another tool that I even don't understand. That's like a big no. The third thing is, what is my responsibility? I'm getting a list of acceptance criteria defined by our product manager. So that's one thing that my responsibility is to cover this list. The other thing is to pass the review process that is handled by our team, by other engineers. So that means that I need to write easily extendable code. I need to write performant code. Those are my responsibilities. My responsibilities is not to worry about sanitation and all the attack vectors. And it doesn't even, I don't even think about it. And even if I do, like I used to think that there are tools that protect us from such things, like WAF. But of course, this is an illusion. But those three main things made me and other engineers really don't like handling with security. And to be honest, it really is not our fault. Why is it not our fault? Because how my manager is measuring me. How am I being, what makes my bonus large? what makes my company like me as an engineer. So 3 things: the amount of features we are implementing, a lowered bug count, and predictability. And let me just say a sentence about each. New feature implemented. So in my team, we are measured on the amount of new attack vectors that we've introduced in the past quarter. Lowered bug count. So in this quarter, we had 50% less bugs than the last quarter. And the last thing is predictability. Not only those 2 matter, but also it matters that we committed to do something in the scope of a sprint, let's say 2 weeks, or in the scope of a quarter. Each company, again, it's different. But we committed to do something, and we were actually able to deliver. This is something that we're also measured on. And if we think about security, it doesn't fit. Like if I'm going to integrate this new step that I don't understand, a lot of noise, I need to talk with with the other guy, this app security guy, it makes me implement features slower. So, and my manager wants to merge the PR because we committed to it in the sprint. So it doesn't naturally fit in the way we are measured. And the way we are measured, again, it can apply to our bonuses. It can apply to how our being incepted in our company. Well, that's until we're breached. So actually, I went ahead and looked up the major breaches only from the past month, August 2024. And we see here some pretty major companies, one being under ransom of $5.8 million. And you might see it and you're thinking, oh shit, that's like only from the past month. That's pretty cheap, $5.8 million. It can go much, much higher than that. And to be honest, it can even not be money. If we're talking about security vulnerabilities in certain industries like health or the automatic cars, it can be life-threatening. So of course, the customers are impacted here the most, getting their sensitive data exposed. But engineers are also impacted by it. Because now as an engineer, of course, this is prioritized. I mean, our CEO wants to fix it right now. And who fixes it? The app security engineer? No, I'm fixing it. It's been prioritized. I need to context switch out of my sprint. Every 30 minutes, I'm getting a message from my manager, when is it going to be fixed? And if there's one thing that engineers hate more than dealing with more tools, than security, whatever, is working under pressure. That's the thing that engineers hate more. And the funny thing is that all of those breaches, actually many of those, I looked into them, and they were done by malicious attackers exploiting pretty common attack vectors, like XSS, like broken access control. And I don't know if you've heard of it, there's a really cool organization, it's called OWASP, and it gathered some lists to actually answer those. It gathered some top 10 lists for us as an organization to understand what are the top attack vectors right now in the industry. So such poor cases don't happen to our organization. Pretty cool organization, OWASP. All right, so now if we're facing, and I'm talking from an engineer point of view, if I'm facing with a choice, I cannot care about security. That means that I'll develop faster. That's correct. I'll push the PR. But later, I'll be under pressure. Maybe a lot of money was impacted. Maybe people got hurt. Again, some security vulnerabilities can make actually not just money implications. And now I'm under pressure to fix it, and I hate it. So that's the cost of not being involved. Or I can be involved in the process. That means that if I'm involved in the process and the vulnerability were catched in the software development lifecycle, we were never vulnerable. So it's not only the time to fix and the context switch, it's also the fact that our company was never vulnerable because we catched it before. So if I'm an engineer, I'm going to choose the latter. I think we all want to choose the latter. Easier said than done, right? But at least now I have a motive as an engineer to choose the latter. All right. We'll talk about each of those stuff. 4 things, but again, here it's just words. So I'm just going to go straight to here. And an engineer we don't know what we don't know, and this is something, it's crucial. Because I mentioned computer science degrees, we really don't learn those cool lists that app security domain experts are doing and researching about in OWASP. Unfortunately, I'm saying it's really unfortunate, but we don't learn those in computer science degrees or engineering boot camps or whatever. And education always is nice, but in the case of app security, let's see how it actually, I like examples, and I like boxes and arrows. So let's see 2 examples of an engineer who's being tasked with implementing a feature and how a conscious engineer who's conscious about app security and vulnerabilities that its code can create, what it would do. So the first example, we need to develop a gateway. We want to develop a gateway that would redirect the client into a certain other microservice in our architecture. So a naive approach, and that's something that a lot of engineers are actually doing, and one of the vulnerabilities that you saw of the companies was because of that, we get the URL of the, as a query parameter. So that when the browser wants to use the gateway that we are now implementing, it will pass the URL where it wants to go, and we will redirect it. It will answer the business requirements of implementing this gateway, but a conscious engineer will suddenly think, wait, getting the URL as a parameter means that a malicious attacker can use this for an SSRF attack. To forge a server-side request means that it can expose sensitive data. So a conscious engineer will say, OK, I'm not going to get the full URL as a parameter. I'm just going to get a certain enum, maybe, that might indicate the service name, like our main backend or our engine. And I'm not going to get a full URL. And that way, a conscious engineer just stopped this SSRF attack from getting to production. The second example is we need to render an input that was inserted by a user to the web browser. And rendering this input, a naive approach would just get the document. We're using document get element by ID, and we're going to render it. But a conscious engineer will say, wait, it's been rendered by the browser. So I need to make sure that this input is properly sanitized and is properly encoded before I render it, because a malicious attacker can use this to run scripts. I'm not even have to be aware of all the payloads and XSS polyglots that he can use to exploit this. I just need to be aware that I need to sanitize and encode. There are tools that are already developed to do that. I just need to think about it and consciously think about it. So here, education is not just a phrase where we want to make our engineers happy and motivated. It actually, in those are 2 examples where we actually prevented vulnerability from reaching production. We got education. All right, so our engineers are educated. We've done the onboarding. We've taught them the different OWASP top 10 lists. And we have a new engineer, Bob. Bob is still in the onboarding process, and he got a rather simple task as an onboarding task to refactor our session creation. We use cookies in our authentication authorization, and this code was a little messy. And Bob was working on that, and while he's working on that, he saw this line, same site strict. It's a cookie attribute. And this line got removed in Bob's PR to refactor. 1 line. Maybe by mistake, maybe because he thought, I'm simplifying things. Why have things that shouldn't be there? Because I'm not aware, or again, even if I'm aware, it's 1 line. It can happen. And it wasn't noticed in the review. And this code was pushed, and we are now vulnerable to CSRF attack. 1 line. So yeah, manual testing, manual thinking, education is enough, but testing those stuff manually, mistakes can happen, and we need to understand that we will reach production if we only rely on humans with vulnerabilities because of such things like 1 line. And actually, engineers already solved this problem. We know we cannot trust manual testing. When we are developing a new feature, we are developing a test for it, a test that passes once we push this feature. And if someone pushes code that makes this test fail, we're telling them, no, you're not going to push this code because you Maybe you implemented a very nice feature that contributes to the company, but you broke the code that I wrote 6 months ago, because we have this automated test. And if we treat functional bugs like this, why don't we treat security vulnerabilities like this? Do we agree that a security vulnerability is a bug? Like if, what's your name? Aaron. All right, so if I'm and Aaron are in the same bank, all right, and we're both registered to the bank, but I'm a malicious user, and I'm able to manipulate the bank API to get Aaron's details, to get his balance, to get other things, do we agree it's a bug? It's a vulnerability. I managed to actually exploit the #1 vulnerability in OWASP top 10, broken access control. Do we agree it's a bug? So why don't we treat it the same? So the way we treat bugs is local testing in the developer's environment. We don't wait for production. We also don't trust that. We also do those tests in CI. And only if those tests, automated tests, are passing, we know that our code at least didn't introduce new regression, at least didn't broke things that once worked. So someone, like in the case of Bob, someone thought about not being vulnerable to CSRF. This is why he made the same site attribute to be strict. But Bob just removed this one line, so this test would have failed if we would have tested ourselves on CSRF. Even if not locally, at least on CI. All right. By the way, how do we do those automations? We're going to talk about it in the end, because I'm going to leave it to the end because there's a little difference. I lied a little bit when I said that we should treat security bugs like functional bugs, because we cannot expect after we educated our engineers to suddenly be security experts. Yes, they are aware. Yes, they are conscious, but they cannot think about all the attack vectors. So we're going to talk about how we do those automations. All right. We're going to talk about how we do those automations later down the road when we get to tooling. So we're now in a good state. Our engineers are conscious. We've integrated an onboarding process that at least covers OWASP top 10 for engineers. And they're thinking about it when they're writing code. Not only that, we also have tests, automated tests, that makes us understand if someone introduced new code, something was broken, a new vulnerability was introduced. But what about our vulnerabilities that already exist in production? What about those? So I worked in a company, I won't say names, that the way it was done, the app security engineer, he hit order by severity, all the critical bugs, that's what you're going to solve in this quarter. And this is, I'm sorry, but this is, I don't know who's the crowd here, and I don't want to offend anyone. But this is a little bit dumb. Why is it dumb? Because first it hurts our R&D KPIs. Product is not going to be on board with it. And engineers are going to think, you are wasting our time. And why? As you already understood, I like boxes and arrows, and I like examples. So let's take an example. We found 2 vulnerabilities. Our AppSec engineer, very talented, found 2 vulnerabilities, whether if it's using manual pen testing, using a tool, whatever. The first one being broken access control. It's critical. The way that the severity is being assessed, there's something called CVSS score. I won't get into it right now. But there's a CVSS score. Very smart guys sit down and thought about what is the severity of each vulnerability. So in our case, broken access control is critical, but it is found in a workday hour submission.internal/submit. The other vulnerability we found is SSRF. It's high, it's not critical, but we found it in our main app/getdetails.com, and those details are sensitive. So SSRF, if we look at severity only, is lower than broken access control. But do we all agree that, OK, an employee can submit a different employee hour? We need to address that. But if someone can use SSRF to get sensitive data about our customers in production, something that is exposed, this is something that we need to address first. So order by severity doesn't work, guys. It doesn't work. What does work? Well, who defines priority? It's product. So we're going to do the unthinkable, and we're going to sit together in a room, and we're going to discuss. Each going to bring its own domain expertise. App security is going to bring his domain expertise about each vulnerability and the impact that it can make. Product is going to add business context to this impact, and together they're going to exit this room with a list that is ranked of those priorities, and they're going to agree on what of those lists we're committing to do in this quarter by combining the business context and the severity. All right, so now we're going to talk about tooling. What do we want from a good tool? 3 things. Coverage, because otherwise, what are we doing here? What does it help us? The next thing is the tool not being noisy. I'll explain a little bit about what noisy means. And the third thing is being easy to use. All right, let's talk about coverage. So we mentioned the OWASP top 10. So we need to make sure that our tool at least covers those top lists, starting with those. So OWASP top 10, OWASP API top 10, and if your application is using an LLM, so OWASP has recently published an LLM top 10. Because every time we integrate new technology into our system, it comes with security risks. We need to understand that. That's why OWASP created an LLM top 10. Yeah, this is an example to broken access control. I already mentioned about it, but this is a tool that can test such stuff. That would be cool. This is number 1 today in OWASP, and the vulnerabilities that we've shown earlier in August, that were found in August 2024, a lot of them exploited broken access control. A lot of the applications today have authorization and authentication mechanisms. All right, not noisy. This is actually pretty simple. A tool that has a large amount of false positives, it means 2 things. The first thing, it means that we are wasting one of the most important resources in a tech company, engineering. Yeah, we just wasted an engineer time who checked, and this vulnerability meant nothing. Why it meant nothing? It can be from different reasons. Automation has it can produce false positives because we are using a certain microservices that the tool doesn't recognize properly, and it handles sanitation for us. Maybe it's code that will never run in production. But it can introduce very critical vulnerabilities, but this code will never run in production, or this third party will never run in production. So waste of time. The second thing is loss of trust. This is something that I've experienced in tools that I've used. I was like, OK, in my team, it was like we knew when we get a list from AppSecurity engineer, we knew it's going to be a hassle. It's going to be a hassle. It's going to be like ticking those and checking lightly. And when you're doing this like this, or eating ignore on some of those, and maybe if the AppSecurity engineer is not picking you because he might not understand, maybe it is a false positive or not that you're reporting on, this loss of trust can be very, very, very expensive. And if our tool produces large amount of false positive, that's where we are going to reach. So a good rule of thumb regarding false positives, again, it depends on the use case. I'll say that. Different applications will, because it's a sacrifice. If we are willing to have maybe a larger coverage, or we're saying, OK, I'm willing to sacrifice coverage for false positive, we need to understand that we have those 2 very, very, very impactful disadvantages. But a good rule of thumb is having at least less than 10% false positive rate. All right, so ease of use. We talked about integrating security, not in the end, but like development is agile. We want to integrate it before we reach production. So we need a tool that would allow that, where if it's an SDK that would allow for a developer locally to test for security, or a CLI, and also for CI integrations, for GitHub, Jenkins, and those kind of stuff. And we want this tool to have integrations with the tools that we are already using. It doesn't count if you're opening a bug in Jira and you're just linking to the tool where I need to go over all the list. It doesn't. We need a proper, if it's not integration, then the AppSecurity and product should do it manually and insert those stuff in Jira, because when an engineer goes to a different tool, it really creates a dissonance. I've experienced it before, and I'm experiencing now when trying to get engineers adopting our tool. Right? So there's another factor, and it's called proof of exploitation, and it touches in 2 areas of what tool would we want to integrate. So proof of exploitation, I'll just transfer here. No, we'll leave in this slide. So proof of exploitation, it helps us two things. If we can have a tool that have a strong proof of exploitation, usually those tools are happening in runtime. Like we run functionality tests, those are happening in runtime. We don't run functionality tests in compile time. We run in runtime. So if it's running in runtime, we're able to provide a very good proof of exploitation, or at least get it from the tool. And it answers two things. One, probably reduces a lot the false positives. But the two, and this is the very interesting thing, it has a very, very big value in an educational value. So let me explain. As an engineer, when you get suddenly a screenshot of someone managing to use your API or use the front-end code that you've written and run a script using code that you've run in a way that wasn't intended to be, that means that as an engineer, you're like, wow, so someone just outsmarted me. We speak that language. We might not know the exact terms, but we speak that language. Someone outsmarted me and managed to manipulate the code that I wrote in a way that it wasn't meant to be manipulated, and we're egoistic. We're now motivated as hell to solve this, and we see the impact with our own eyes, and that's being done with a proof of exploitation. So it's also helped to education. If we can get it from our tool, it helps educating our engineers on the impact. So this is an example for like request response. Some tools go as far as providing screenshots. Actually, there's an open source tool developed by OWASP and maintained by OWASP. It's called ZAP. It does runtime exploitation, and it can provide request response proof of exploitations that could help engineers see the impact and fix it, and also be educated. All right, so the last thing, and this is something that also I see a lot of people fall, is how do we evaluate our tool? And we shouldn't go blindly, just go use a tool. There's actually applications, open source applications that are vulnerable. They publish the vulnerability list that they have. And we can, if we are thinking about integrating our tool, we can run those on those vulnerable open source applications that have vulnerabilities in their source code to see how it behaves, to see how the flow is going. So this is actually a good flow to evaluate yourself on a tool, on a source code that has vulnerabilities. OWASP Juice Shop, Broken Crystals, DVWA, BWAP, there are many more. Yeah. All right, so we are at takeaways. Show us why it matters. Development is agile, and security testing needs to be agile as well. When it's noisy, we lose trust, so don't sacrifice, don't be lightheaded to sacrifice coverage for false positive. Because if we have a tool that, I see a lot of app security engineers are getting hot. This tool finds a ton of vulnerabilities. But if 50% of this is noise, then this means that this is not valuable, and it hurts us a lot down the road where the engineer that actually needs to fix it is hurt. And the fourth thing is integrated into the tools that we already use. Don't make us use another tool. And those things that we've just talked about throughout this talk will make engineers actually want to adopt app security. Right, I finished a little bit ahead of my time, and now it's time for questions, I guess. Any questions? Yes. Yes. I definitely agree, and actually, maybe I missed my point when, in further ahead, we all agreed that one of the KPIs that we are measured on, a lowered bug count, is considered in the lowered bug count. A security bug is part of our lowered bug count KPI. We should be measured on it. And those, like if we wanted to reach 15% less bugs in this quarter than previous quarter, we include both functionality bugs and security bugs. Because security bug is a functionality bug. We should treat it the same. You mean the KPIs? So KPIs for program managers should include security bugs. Otherwise, program managers will never ever allocate the time for security. I agree. I agree with this. I'm not a product manager, so I actually don't know all things that product are being measured on. But probably it should correlate with what R&D and engineers are measured on. And if me and my manager we are measured on a lowered bug count, then if we didn't reach a lowered bug count, that means that our KPIs have been hurt, and we are the ones who are executing it. But I do agree that the product KPIs should definitely correlate with it. And the second comment is about the integration of OWASP or whatever the issue is from, but that specifically one answer about here is integration into your CI pipeline. So you don't need to be accurate. Can you please tell me what is the average boot time? You mean the test time of this tool in CI? You push to the code. Yes. What's your average boot time? You can come up with a number. Like the compile, you mean, or to develop? Let's say 5 minutes. Let's say yeah. So that depends. That depends. That's why we need multiple layers. What we choose in CI should be applicable to the 10, 20 minutes range. Yeah. So in my experience, the shortest CI test was about 55 minutes, average about 8 hours. So you are really hurting the development. So just because I worked a lot, I implemented in the previous organization I worked for, I implemented that as a service inside of the organization using one of the tools. So I spent a considerable amount of time doing it. So in integration of tasks into CI pipeline is counterproductive. And that not just is counterproductive in itself. The problem there is that you will have false positives. As you rightly so mentioned, if you cover those false positives, it creates a canal. Let me address that. All right.
Otherwise, very not true. That's only true for legacy DAP solutions. There are modern DAP solutions that address all of those problems. Well, I worked with 4 or 5 of them. I would love to give you a demo and show you.
I'll give an answer. I'll give an answer.
You've been working for 5 years.
I'll give an answer. I'll give an answer. First, it's use case dependent. On some entry points, if your entry point has one entry point has a lot of parameters, then you're saying, OK, even a simple test in runtime can take a lot of time. And here comes the trade-off. So if you're saying this is my use case, then I might want to integrate it in a pre-production environment, in a remote environment. But most use cases, like you're running tests in runtime, unit tests, and integration tests, actually, most cases are also being run in CI. You deploy a Docker container, and you test your APIs on it. If you have a reasonable amount of parameters, and you choose specific tests to run a sanity, it shouldn't take more than 10, 15, 20 minutes. Those should be the limit. If your use case doesn't fit that, then you can go to other stuff like integrating static tools, which give faster input, but validating using a runtime tool. This is also an approach. It's use case dependent. And I agree that if your minimum entry point has a lot of parameters, then you need to think about how you integrate it without overcoming like this threshold of 15, 20 minutes in CI. because it will hurt the development runtime. Maybe in this case, you want to say, OK, I'm willing to push without a runtime check, but I'm not willing to deploy until my nightly runs has at least ran on a pre-production environment, remote environment. And I'm saying, OK, now I know that my security posture hasn't been impacted, and I'm willing to deploy. Yeah. Yeah, there are different use cases. The thing that I will say, first of all, yes, there are different use cases. You need to start with something. If you have nothing at the moment, so once a week running those is better than nothing, for sure. Then you need to see how you move forward from there. Yeah. More questions? Anyone else? All right. Guys, I enjoyed much of this talk. Thank you very much. One last thing. Thank you. One last thing is, I don't bite. Feel free to come and talk with me, whether if it's about how to get engineers to adopt app security, web security engineering concepts, or something that is not geeky. Feel free to reach out. My mail is posted here, but you can also come and I'll put my details here so everyone can see. Yeah, thank you.